Okay, I hope everyone can hear me now. So, welcome on our first webinar, Moving Forward from Legacy Systems. My name is Jerzy Zawadzki. I'm the Chief Technology Officer at Polcode. First of all, I want to welcome you all here. Thank you for being with me today. Before we would start, a couple of words about us, about Polcode. We are full cycle web development software house from Poland. We help companies, e-commerce startups, software as a services companies from all over the world with their web development. And unlike other software teams, you will easily get to know and trust our experts who will become a core part of your company operations and success. We are more than 14 years on the market, and during that time we completed more than 1,300 projects. We besides that, we are rated 5-star on Clutch, and we have 98% job success on Upwork. So, short description on what we have on our plate today. I will start with short introduction on software quality, as I believe all discussion on legacy system should start with software quality. After that, I will try to answer three important questions. So first, what we are dealing with, what it's all about. Second, how to know that we are having a problem in our software application. And third, how we can fix that, the most important one from today's talk. After that, I will have for you a couple of case studies from my experience about refactoring legacy systems. And after that, a small discussion on how we can prevent that in the future, those problems that we mentioned in the first part, how we can prevent that in the future. Not only fix problems, but how we can prevent in our software. After that, we will have this small bonus for all our today's participants and short Q&A session. If you have any questions during my talk, you can put it in the question and answer part in the Zoom menu. I will answer them after the talk within the Q&A session. So let's get started. I would start with a small sentence, but very important for me, as what I learned from my experience as a software developer. There is only one constant in the world of software, and this constant is change. I saw many projects, many specifications, and never single one have become final. So there was always something that has changed during the either development or during the use of the applications that I saw. And it's not bad. It's most common reason for that is time frame, as software can sometimes take a couple of months, sometimes a couple of years to create with the bigger projects. With this time frame, world does not stop in place. So the world is evolving, and so our software should change to this world accordingly. So that we should embrace this change, and also our software should embrace it. Therefore, I think it's the whole discussion here, it's the two-way conversation. So first we have some business change, of course, that affects our software, affects how we build it, and how we can change it to get this business change in place. But there's also another side of it, because how well we created our software, how easily it can change to the world, and this allows business change to take place. So this is the two-way round in my opinion, and it's all starts with the software quality, because I see software quality as a also we have two sides of it. First one is the external quality, which is about the correctness of the software mostly. So how well is the software is doing something, if it's correct, if it's fast, if it's efficient, and many more quality characteristics we have here. Internal quality is about maintainability and with allowed pace of change. I believe that product owners not often see the bad codes. They should be technical to see bad code, legacy code, but what they see is often is the effects of the bad code, mostly in the allowed pace of change. Uncle Bob, Robert C. Martin, famous Uncle Bob, said some time ago that there's no trade-off of quality versus speed in software. There never has been. Low quality means low speed, always. And the sentence I really like, the only way to go fast is to go well. And it's exactly about this internal quality I talked just a second ago. The only way to go fast is to go well. Sometimes we can't go fast and we repeat as a mantra that we can't go fast because our code is legacy, because we have some legacy. So what does the term legacy system mean at all? I chose three quotes that I found on the internet that I really liked, and they show different perspective on legacy systems. First, that legacy is code written by others or under a previous language, architecture, methodology, or framework that pertains to the current project. Second one is the legacy is code without the tests. This is quote from the Michael Federer's book, Working Effectively with the Legacy Code. And third, that code is legacy code as soon as it is written. This comes from the single notion that 90% of the developer work is to read the code, and it's easier to write the code than to read it. So therefore, we basically create the legacy code from the start. My perspective is a little bit different on that. I believe that systems are not legacy from the beginning, and not becoming legacy, but by mm, themselves. Systems are becoming legacy, becoming rotten as we change it. What I believe, there are problems that really matters are mostly on architectural level, not the code level, not the single line on the code problems. If you have problems on the single line, they don't affect your business as much as problems on the communication between modules on the architectural level.
So how we got to that point that we have problem in our code? Uh, I found 5 most common reasons that we got to the rotten code, the legacy code. Mostly it's often the code written a long time ago, which was not updated, was not changed as we go. For example, something written 1 or 2 years ago, and also not maintained. No updated dependencies, no not updated framework with high technical debt that was not paid quickly or not paid at all under unsupervised architectural growth. So those two points, the high technical debt and the unsupervised architectural growth, I think are the most common that I saw in my career. Technical debt is something that is considered bad, but it helps you for faster pace sometimes, but it should be paid as soon as it's possible. So in teams which has really problems with legacy code, this technical debt was just bigger and bigger every week, every sprint. And also what I say with by under unsupervised architectural growth, sometimes applications are thought to be really small and the business changed and it was need for the additional functionalities, maybe some changes. And on this really small base, the really big system was created. And this small base couldn't handle the number of features, maybe a number of users, or maybe number of data points in the application. And last one, new team and undocumented code. Let's say your team has gone away, something happened, and the new team come to the code, which sometimes is not documented at all, and need to reverse engineer how it works. It also, even though this code could be written 1 week ago, it's become a legacy because we need to find out what it does. But I think what's most important is for business people that business don't really see the bad code, because normally they don't see on this level. But I believe that business can see the effects of the bad code. So I listed some symptoms that we can tell that something is wrong in our code. So first will be the slow progress with new features, increasing number of bugs, fragility side effects. So those three are the most common symptoms I saw in the legacy code bases. Slow progress with new features. If you see that new features that are created are creating slower and slower, it's not only that pace is slow from the beginning, but it's becoming slow as we go, as we add new features. Increasing number and bugs and fragility are connected, because the biggest problem we have when we see the bug in the part of the code we didn't even change in that sprint. So this comes to to thought that our code is fragile, as we change one thing and there's a problem in completely different unrelated thing. So if you will go to the car mechanic and with your broken window, so your window is not opening automatically, and you leave your car at the mechanics, and he call you next day that, okay, your Windows is fixed, and you try it and it works, but your engine doesn't start. It's like that with software development with the legacy code base. You can have problems with finding new developers, like some, I believe, airport in France that have really old code base, and all the developer that maintained the code has retired. So they had really problem with finding new developers, and high cost of the infrastructure, and also change of costs. So if the cost is increasing every week or every month, and what I call the ultimate failure of the code base, it's saying that someone is coming to the developers and say to them, do not touch that code. And that code can be single class, single file, single module, or single web application. Do not touch that code, because every time someone touch that code, something breaks. So there is a so-called ultimate failure. Do not touch that code. But there may be a solution. So let's fix the problems that we found. If you can see those symptoms that I mentioned, that means that there are some problems in your code base. So how we can fix this? We basically have three options to fix legacy code base. First, leave it as is. Second, refactor, and three, do the complete rewrite of the code base. Leave it as is may sound weird, but sometimes is the best solution. For example, if we are building some kind of prototype, or we are building the code that should last, for example, 2-3 days, and it's not used anymore, there may be not really good reason to refactor the code. However, this one is tricky, because as I said on the beginning, there is always some change. So this situation can change. We can think that, okay, this code will never be used anymore, but next week or next month, situation can be completely different. On the other side of the spectrum, we have the complete rewrite. Rewriting, from my experience, from my career, I see that rewriting software from scratch is almost never a good idea. Why? A couple of reasons. Most important is that old code works. The old code works. It's doing its job mostly, maybe not in the best way, but it allows you to get money, get some investments, get new clients, and new customers on your code base. So it's to some extent, it's doing its job. When we're creating new code, there is possibility of new bugs, because when we look at the legacy code base, the old one, we see only the effects of the development that could take a couple of months, a couple of years sometimes, and we don't see this history. We see only effects. So how we can be sure that we would not make the same mistakes? I believe that someone who created the system have a good feeling, was doing his job as good as they can, and they still have problems. So how we sure that we would not make the same mistakes? There's a knowledge hidden in old code. I saw sometimes when some team has started to rewriting the software, they take the old one and do the reverse engineering of this code. So basically, they created a new code, they went to the old code and see what this code does. This should start, even though, with the business, not with the code, because if you will just rewrite the code, you may make the same mistakes as in the previous one. Mostly, it's time consuming. From time to market perspective, it's blocking new features. And in the worst case scenario, we are developing two versions in the same time. So we are creating the new version, and still, for example, it takes 6 months to create the new version, but in the same time, market and the business require that we ship new features, and we try to do this on the previous one. So we have, for example, split team. That one is still changing the old one, the old system, and one part of the team is creating new one. It can be really complicated. And last, of course, but not least, cost. Sometimes, of course, that's why I said this is almost never good to consider rewrites. There are some situations that it's okay to consider it. First of all, if old code cannot be trusted completely. So if you have something that doesn't work at all, pretty much, you can't trust the code inside. That is good. That may be good to consider rewrite. Really small, simple, well-known business domains. I know some applications, for example, in the US, that are rewrite every 1 or 2 years with the updated version, but they have really simple domain that is not changing very often. They know it very well, so they know what they're doing. Business logic has changed completely. So if you have a completely new idea, that may be good to create from scratch. And if you're migrating from the long, unsupported, unsecure stack, so something was created 4 or 5 years ago, and you basically cannot install it because it's not secure anymore, or versions that you are using don't allow to install it. So this is also a good way for rewriting, because you wouldn't be able to make updates easily, for example, 4 or 5 years ago from those all changes. So when we left the option for the leave it as is, we are left option for complete rewrite. We stayed with the refactoring of the code base. And to start the refactoring process, the first and the most important thing is that you need to have a plan. So I think it's the most crucial factor to success in the refactoring. I prepared a short list of questions that you should ask yourself, and you should ask your team, your development team, about the application. Those answers will guide you through the refactoring process. First, where you want to be in 3, 6, 12 months from now, business-wise. Because if we see the refactoring, we sometimes only see the features that are right now. We must see the whole picture, and also to see which part of our code base would block us with those business goals that we have with this application. If we know that, for example, module A is really bad, but there will be no changes in this module, for example, in next 6 months, but we have module B that will be changed, or we have new features, something like that. This one should be taken care of. What are your biggest bottlenecks with the current architecture, and which modules work best? This will help you to decide with those business goals in mind that I mentioned just before, which to start refactor with, and which modules are the most problematic. Are there any features that are not used anymore? If we have less code to refactor, then better. So normally the 20% of features is doing 80% of the job, of the money. And sometimes there are features that were created long time ago and wasn't that not using by anyone. Google is great for killing some of the systems applications that are not used, just to lower the cost of maintain of those systems. So maybe in your application there are also such features that are not used anymore. So we could remove this code. Are we using latest version of the all dependencies from the language level, the framework level, and the library level? And we have the business side in mind, the future, those business goals, and the perspective of the technical. We now can see which part to refactor first. And this is most important, I believe, slide on my presentation. Do not refactor for just sake of refactoring. Code was created, code works. It may not be really good to refactor it. We don't really need this. If, again, this code will never change. Refactoring for just sake of refactoring will create just only additional bugs and time for testing and pretty much sometimes lower the maintainability of the code. Plan new architecture and isolate the legacy part. If you know which module to refactor, you have the plan of the of going forward. Now you should create how this should look like, how your application and your architecture of it should look like. And you should simply take what's now and isolate it so it not affects the new code. Best is to create the interfaces from the object-oriented point of view, and close and new interfaces, the good ones already, and close the legacy part behind this. So you can create a new application, new parts of application that are not affected by how it's designed, the legacy part. So if you create the new part, then you can easily change this part because this part has no dependencies on the code. And 3 rules to do it safe. First of all, and the most important, have working test suite. Basically, you shouldn't start refactoring any changes in the code without working test suite. If somehow your application don't have the test suite, start working with the end-to-end tests. Normally, the most important are the unit tests. However, those units that you are creating will be changed during the refactoring. So in terms of refactoring, if you approach this without the test, end-to-end tests are better because you want to create the application one-to-one. So you can write the test, which take the whole, for example, one feature or one site on the web application. You want to change the code, and end-to-end test will easily confirm that it works just as it should. Second part, about mark critical paths. Every system have some most important features. So for example, In the banking application, it will transferring the money. For example, in maybe some social system that will be adding someone to a friend or something like that. Mark which parts of your application are critical and which may need additional testing for after the refactor. Those critical paths are the features that whatever happens, this must work in your application all the time. And third, do not refactor all at once. Make it small batches. Write test if you don't have. Refactor a single file or single module. Run the test again and go forward. And as I said, two small case studies from my experience, two different case studies that I prepared about the refactoring. First is about data processing application. It doesn't matter what business is about. I will show you what problems that we had in this application, what problems the customer came to us with to fix maybe. And I will go on more technical level. First, we have data processing application based on the single MySQL database with more than 100 tables. There's a single most important table which have more than 300,000 records. In the biggest table was about more than 1 million rows in the biggest table. So not maybe really big MySQL database, not close to the biggest I saw, but it have some different problems. First of all, it was edited directly by customer. They used some tools to edit database directly, as it is really easy. But this also affected how this database was built. It was denormalized, so there was no identifiers to all the tables. Pretty much the most important things were in the one tables with the string columns with the IDs without any relations. And beside the direct addition of the data, there were some kind of two or three tools that made changes to this database. There was some administration tools for users and so on, and some data processing tools that added or edited data in this database. And on the other side of the image was the front side, user-facing side, the customer-facing side, which used the data in the MySQL, which was built with the really old PHP version with a really long controller file, 6,000 lines in one controller, so really bad, with old design, outdated design, and it was working very slow. And the slowness was because of the database, because how it was built, how it was architected. So we thought about options, what we could do, because the problem is here. The front part and the slowness of the front part should be fixed. Also, design should be updated. So what we did in the first step is that we left the database as is. And this is a crucial part of the application. The data is in this database, and put the Elasticsearch up front. So we created the synchronizers for the data that took data from the old MySQL and put this into the Elasticsearch indexes, and created a new front based on the Elasticsearch data with the newest PHP version, new design. It was because of using Elasticsearch, it was ultra fast. We also added many new features, including reporting, which wasn't really possible with the design of this database. But this is not the whole story. This is only the first step that allow us to make changes, because we did the step number 2, second step, that okay, we are now in the moment of time that we have the new front, we have more users, and this front works, and we can now put more effort into fixing original problem with the new database. So after step two, it was looking like this, that we created a new proper MySQL schema with proper indexes, with proper relationship. We created a new admin tools, new data processing tools, and create a simple migration process for this. Only thing we need to change is the synchronization to Elasticsearch, but the front before after the step one wasn't changed because it was splitted from the MySQL and it was still using the Elasticsearch. And lesson learned from this case study is simple, because refactoring, in my opinion, is part of compromise. So we couldn't change this in the one step because it was a too big investment for the customer. So we find a way to first change most important part, the user-facing part that is making the money. So this was changed, and after that we have the clear plate to change the backend of it. Case study number two is about the e-commerce. Subscription-based e-commerce, to be exactly, built on the WooCommerce. This is the WordPress solution for the e-commerce side. It's important that it's not the usual e-commerce, but it's based on the subscription model. And it's physical subscription. It's not digital subscription, but with specific packages and specific products that are going to customer every month. So customer came to us with two problems basically. First problem that we found, that the code have too many responsibilities. The single code base based on the WooCommerce has the customer-facing side, has code for processing subscriptions and the recurring payments of it, and all the logistics. Basically, the WooCommerce was about every part of the system, customer facing and the backend, and to say to who I must send which product on which month. Plus, we have the second problem, business opportunity, business change, that on the application, on the previous one, there was only a single subscription type, single, let's say, product, but the customer wanted to add a new subscription types. So there is a first our legacy code base, and second the business change, that it's pretty much not possible to do, because there was a possibility that if we would add a new subscription type or to the system, it will broke the old ones. So we would need to change the system. Also, there was the ideas of changing the design of the site, which is also not really good idea, because if we change the design, there's also possibility that we will break the processing subscriptions and logistics. So what we do, we start with the business changed with this problem number two, and we create separate tool built on Symfony framework, this tool for processing those new subscriptions only, those new subscription types only. So after this step, the WooCommerce was sending the new orders to this tool, which have the all processing code and the logistics for the new subscription types. Woo was taking care of the old types, working as usual. There was only change for the customer-facing side to add new product, but all of the processing was of the new orders was moved to the Symfony part, and that allowed us to do second step of the refactoring, because if we had the application that we are sure that is working with the new subscription type, because the tool we proved after 1 month that okay, it's working very well with the new subscription type, so we could add the old ones to the new tool. So we migrated all of the subscription types orders to the Symfony page. So after step 2, we cut down the WooCommerce side to only be customer facing. Because of that, right now, WooCommerce can be easily changed, for example, to something other e-commerce engine, design can be updated without worrying of the processing side. So lesson learned from this case study is simple, is that architectural refactoring is about separating responsibilities. We want to be sure that change, as I mentioned before, change in one part of the system will not affect the other. Refactoring is not really hard on the code level, on the single code, but it's really important and really hard to do on the architecture level, because this level really matters for the business. We didn't change here the code for the WooCommerce, the code itself, but we split responsibilities on the architectural level. It's sometimes called not refactoring, but re-architecting the code. So when we would have the new code, that code which works, how we can be sure that we will not make the same mistakes in the future? So how to avoid software rot that I mentioned on the beginning in the future? First of all, and most important, document your code. Write the architect decision record. So sometimes sometimes the documentation is written just to sake of writing the documentation. And the most important things just being lost in time. So ADR, which is architecture decision record, allows you to remind yourself why you did like you did in the code, why you choose this solution, why you choose this framework, why you put this decision. So ADR, you state the problem, you said what options did you have on the specific time, and what was the solution, and why you choose this one for the application. You can put this in the documentation for future reference. And also write technical debt, because sometimes technical debt can be hidden from sight, but it should be clearly visible. Okay, in this module I had a technical debt because of this business requirement, and we need to pay this debt. We need to do following parts, and if we don't do this, this will happen in the future. So write this down, and most important, as I said before, pay up your technical debt regularly, because like with any other debt, there will be the increasing profit on this from the debt. Hey, high test coverage, so you don't need to write test before refactoring. I hope this goes without saying. Choose frameworks and libraries wisely, so they are sure that you are sure that they will have the support in the future. Upgrade early and upgrade often. We may choose from the long-term stable versions for example, our frameworks, but we could also upgrade early, and which I would recommend. We'll not stick to LTS, but upgrade as they are, because it will allow you to go faster, and will not the upgrade for the next LTS version would take much more than upgrade for every single one. And the rule that I really love, the Boy Scout rule: leave the campground cleaner than you found it. In software development, it means that if you are changing some code, you should already test it, because you are changing it. So this is a good time for the refactoring and change on the code level. So we speak about the changing on the architecture level, and the Boy Scout rule is really works really well on the code level. To just if you are in some class, in some module, you need to change this because of some business requirement, then you should also clean this just as you go. To sum up my today's talk, just 6 or 7 small points. First, plan your refactoring, your moving forward with business in mind, and that's why we call this talk moving forward, because sometimes it's shown as the recovering from the legacy code. I really wanted to show you that there's a light in the refactoring. So refactoring and changing your architecture will allow you to move forward. But to move forward, you need to know which direction we should go. So that's why plan business in mind. Cut down unnecessary features, less code, less bugs. Safety first, including tests I mentioned. Refactor rather than rewrite. Isolate the legacy part so it not affects the new shiny code, and avoid software rot in the future with those rules that I shared with you just moments ago. And most important for me is to have a good technical partner that can help you make technical decisions based on your business needs. I think it's the crucial. And that's why we prepared the bonus for you today, which is the expert consultation. There's the possibility to chat one-on-one about your legacy systems and what options do you have to move forward. There's a light in the tunnel, so that's why we chose this bonus. I will run right now the poll on the Zoom meetings. You should see this. Do you want to chat one-on-one about the legacy system? So you should be able to see the poll right now. Okay, that's all. That what I have prepared right now. Let's move to the question and answer sessions. We have couple minutes right now for this. Looking for the answer. You could use the question and answer feature of the Zoom or the group chat. I will let you write your questions, if any, and we'll see what's here. Okay. Okay, I see two questions. So just give me a moment. Okay, first is about the cost of the refactoring. How can we lower the cost? Yes, I didn't mention the business perspective of the refactoring, the cost of the refactoring. As we said, the cost of the complete rewrite can be really high. That's why we don't do it in most of the cases. And the cost of the refactoring, when you have some already kind of changes from the business perspective, you can connect those changes to your refactoring. So, for example, if you have really bad code base in many places, it's across the whole system. For example, if you want to, it's good to connect those changes, this refactoring, for example, with updating the design. Because if you are updating the design, you must change whole application, all modules, and you still need to test. So you can lower the cost of refactoring by connecting this with such features. So you only test once after this. But this can be tricky. If the refactoring is really hard, it's easier to compare one-to-one. So this should be also to your decision. But for example, design change could be a good option for lowering the cost of the refactoring. Refactorings are notoriously hard to estimate. Any tips? Start small. Start with planning, and start with maybe not go too far in the future, because we should be able to estimate, for example, one module that can be refactored. Those problems with which you mentioned about the estimation comes from this. If you change one model, the other part can already change. because if you have your results from refactoring the first module, this estimation could not be really good right now because you know more about the project. I would start with estimating the analysis from both business and technical standpoints. Then we should be able to have the plan and go one by one with any module of this. About the cost overall of the refactoring, and to find the money for the refactoring, please also consider the cost of not doing the refactoring. How much it would cost you and your business not changing the legacy, the rotten part of the system. It's also on the page of the cost. Okay. How to tell from code point of view that it's legacy and it's rotten? As I said, we looked from the business side to see how the code is rotten, it's legacy. We can also see from the code. We normally use many tools to see quality of the code, including the static analyzers of the code, to see connections of modules, because as I said, those side effects could be really problematic. So the static analysis of the code will show us which classes or which modules are so-called God classes that are used with, for example, all parts of the system. There is also good idea to use tools that analyze the history of your repository. Every project should have the version control repository that you can see code in every point of time. And there are tools that will show you how many times specific class or module have been changed. Because if you see the code as whole in the current state, you don't see how often specific module have been changed. So if you use one of such tools, you can see, for example, this module was changed every single week. So this module means that have too big responsibility, and it's crucial for the system. If, for example, some code was not as good, but as it was written, it was not changed throughout a couple of years right now, it's good to leave this as it is. But if something is changed very often, that is good part to do refactoring. There are some such tools for the Git repository, and they are really helpful to see the state of the history of the project. Because when you have the module or class that has been changed, for example, 15 times in the next in last 2 months, there is a good percent of chance that it will be changed in the future. Okay, I think there are not any questions more. Okay. And one last slide. So if you don't have any more questions, I would like to thank you for being here with me today. I hope that is not our last webinar on software and web development. Thank you again for participation. Have a good day. Bye.